Welcome to the AEON-CASIMIR Initiative, a groundbreaking approach to propulsion physics that challenges everything we know about moving through space. Developed by Colonel James Hartman in Northwest Indiana, this project introduces a new paradigm: propulsion without thrust. Instead of relying on traditional engines and reaction mass, AEON-CASIMIR leverages advanced physics, Casimir boundary effects, relativistic field theory, plasma electrodynamics, and metamaterial science to achieve movement by reindexing the very fabric of spacetime around a craft. In this video, we'll explore the core principles, technical breakthroughs, and the rigorous science behind this revolutionary system. AEON-CASIMIR is not a speculative venture. Every aspect of the dossier is rooted in peer-reviewed physics, with no reliance on unproven or hypothetical technologies. The project's scope is clearly defined. It's a clean, high-rigor reset that builds on established scientific domains. This means every diagram, calculation, and technical plate is meticulously attributed and standardized. The focus is on Casimir boundary physics, relativistic field theory, plasma electrodynamics, and stress-energy tensor engineering, ensuring that all advancements remain within the boundaries of accepted science. Traditional propulsion systems depend on force generation, pushing against something to move forward. AEON-CASIMIR turns this idea on its head. Here, movement is achieved through directional inertial decoupling, using asymmetric vacuum pressure gradients embedded in curved spacetime. The craft's local inertial frame is redefined, so it's not the vehicle that moves through space, but rather, spacetime itself shifts relative to the craft. This radical approach eliminates the need for reaction mass and opens the door to entirely new ways of thinking about motion. At the heart of AEON-CASIMIR propulsion is the Casimir effect, a quantum phenomenon where vacuum pressure arises between closely spaced conducting boundaries. This pressure is real, experimentally verified, and acts perpendicular to the surfaces. AEON-CASIMIR advances this concept by introducing dynamic boundary spacing, phase-modulated cavity geometry, and metamaterial-induced vacuum anisotropy. By creating a directional Casimir gradient, the system generates a stress-energy source term, which becomes the engine for movement without traditional thrust. AEON-CASIMIR's approach is deeply rooted in general relativity. The modified stress-energy tensor includes not only matter and plasma terms, but also a Casimir vacuum term and boundary contributions. This addition biases spacetime curvature locally, allowing the craft to manipulate its inertial frame. By integrating these terms into the Einstein Field Equations, AEON-CASIMIR achieves local curvature gradients and metric index variations, enabling the vehicle to follow a geodesic minimum, appearing to accelerate without exchanging momentum with the environment. One of the most remarkable outcomes of AEON-CASIMIR propulsion is the reduction of effective inertial mass. By shaping the vacuum potential through Casimir cavities, the system can reduce the apparent mass of the craft. This means less resistance to acceleration, no internal g-forces, and no structural shock during extreme maneuvers. Importantly, this is not actual mass loss, but a reshaping of the inertial frame, allowing for unprecedented acceleration tolerance and maneuverability. AEON-CASIMIR propulsion doesn't break the rules of Newtonian gravity, it redefines them locally. In the weak field limit, the system alters the local vacuum energy density, allowing the craft to hover in planetary gravity wells, lift without aerodynamic surfaces, and maintain stable station-keeping. Newtonian gravity is preserved at all scales, ensuring compatibility with established physics while enabling new forms of movement. AEON-CASIMIR defines several distinct propulsion modes, each corresponding to a specific vacuum configuration. Hover mode uses symmetric Casimir cavity phasing, translation mode employs a forward-biased vacuum gradient, and acceleration mode ramps the metric index over time. Turning is achieved through tensor rotation without lateral force, and extreme maneuvers are possible via inertial tensor decoupling. Notably, there is no thrust vectoring. Movement is achieved entirely through spacetime manipulation. Maintaining stability and coherence in the vacuum-metric system is critical. AEON-CASIMIR achieves this through phase-lock plasma rings, metamaterial resonance tuning, and boundary feedback control. Decoherence, which appears as noise in the stress-energy tensor, is actively damped using advanced feedback mechanisms. This ensures the craft remains stable and responsive, even during complex maneuvers or rapid changes in configuration. Every technical diagram in the AEON-CASIMIR dossier adheres to strict standards. Each plate includes true cutaway geometry, Casimir cavity lattices, plasma ring topology, field vectors, and embedded tensor equations. The scale ladder ranges from Planck to cosmic, and every diagram is attributed to Colonel James Hartman in Northwest Indiana. The resolution is locked at 4096 x 4096, using an engineering palette with no artistic abstraction, ensuring clarity and precision. The first phase of the AEON-CASIMIR deliverables focuses on the core concept, propulsion without thrust. This chapter establishes the foundational physics, supported by a 4K plate showing the Casimir cavity propulsion cutaway. The emphasis is on how metric reindexing replaces traditional momentum exchange, setting the stage for all subsequent advancements in the dossier. In the second phase, the project delves into vacuum-metric coupling, exploring how the stress-energy tensor is mapped and manipulated. This phase is accompanied by a detailed 4K plate illustrating the mapping of stress-energy tensors, providing a visual and mathematical foundation for understanding how the craft interacts with the vacuum and spacetime. The third phase focuses on inertial mass engineering. Here, the dossier presents both the theoretical and practical aspects of reducing effective inertial mass through vacuum modulation. A 4K plate details the effective mass tensor diagram, showing how the system achieves reduced inertial resistance and enables extreme acceleration without structural shock. Conventional aerospace propulsion is built on the principle of momentum exchange, where force is generated by expelling mass in the opposite direction. This approach imposes strict requirements: reaction mass, thermal and mechanical stress limits, and significant inefficiencies at relativistic speeds. Structural failure becomes a real risk under extreme acceleration, limiting the possibilities for advanced space travel. AEON-CASIMIR abandons the need for momentum exchange by introducing metric reindexing. In this system, the craft's inertial frame is modified relative to the surrounding spacetime, allowing for movement without pushing against anything. This shift in perspective is fundamental, as it opens up new possibilities for propulsion that are not constrained by traditional physics. Motion in the AEON-CASIMIR system occurs when spacetime is made non-uniform around the vehicle. Instead of pushing against the environment, the craft creates a local gradient in the vacuum stress-energy tensor. This forces the geodesics, the natural paths through spacetime, to shift relative to the vehicle, resulting in movement without traditional force generation. A key governing statement in AEON-CASIMIR propulsion is that the vehicle itself remains inertial, meaning it does not experience acceleration in the traditional sense. Instead, it is spacetime that moves around the craft. This subtle but profound distinction is what enables the system to avoid the limitations of conventional propulsion. Quantum vacuum energy is not uniform when boundary conditions are imposed. For example, between parallel conducting boundaries, the Casimir effect creates a measurable vacuum pressure. This pressure acts normal to the boundary surfaces and exists without any particle exchange. AEON-CASIMIR exploits this property by introducing controlled asymmetry, turning the vacuum itself into an engineering medium. By making the separation between boundaries anisotropic and time-variant, AEON-CASIMIR creates a directional Casimir gradient. This gradient introduces a new term in the stress-energy tensor, which redistributes energy density spatially without violating conservation laws. The result is a system that can generate movement by manipulating the vacuum itself. The directional Casimir gradient relies on phase-separated vacuum modes, represented by different energy densities on either side of the boundary. The boundary geometry and orientation are encoded in the stress-energy tensor, allowing precise control over how energy is distributed and manipulated within the system. Despite its unconventional approach, AEON-CASIMIR does not violate any conservation laws. The system works by redistributing energy density within the vacuum, rather than creating or destroying energy. This ensures that all movement and manipulation of spacetime remain consistent with the fundamental principles of physics. The Einstein Field Equations are at the core of general relativity, describing how matter and energy shape spacetime. AEON-CASIMIR modifies these equations by adding Casimir and plasma terms to the stress-energy tensor. This leads to local curvature gradients and metric index variations, allowing the craft to follow a geodesic minimum and appear to accelerate without exchanging momentum. With the modified Einstein equations, the craft is able to shift the flow of geodesics around itself. This means that, to an external observer, the vehicle appears to accelerate, even though it is simply following the path of least resistance through a locally curved spacetime. This is a key feature of AEON-CASIMIR propulsion. The vacuum-modulated potential, represented as 5Ac, is central to reducing effective inertial mass. By controlling how this potential changes over time, AEON-CASIMIR can decrease the resistance the craft experiences during acceleration. This is achieved without any loss of actual mass, but rather by reshaping the inertial frame itself. One of the most profound implications of AEON-CASIMIR propulsion is the elimination of internal g-forces. Because the craft's inertial frame is reshaped rather than accelerated in the traditional sense, occupants experience no structural shock or acceleration forces, even during extreme maneuvers. This opens up new possibilities for high-speed travel and rapid directional changes. AEON-CASIMIR's ability to alter local vacuum energy density allows the craft to hover in planetary gravity wells without the need for aerodynamic surfaces or reaction mass. This capability is a direct result of modifying the effective energy density in the Newtonian limit, enabling stable station-keeping and lift in any gravitational environment. Even as AEON-CASIMIR redefines local energy densities, it preserves Newtonian gravity at all scales. This ensures that the system remains compatible with established physics, allowing for seamless integration into existing models of planetary and cosmic motion. In hover mode, AEON-CASIMIR uses symmetric Casimir cavity phasing. This configuration creates a balanced vacuum pressure around the craft, allowing it to remain stationary relative to its environment without any thrust or aerodynamic lift. It's a stable, energy-efficient mode ideal for station-keeping and gentle maneuvering. For translation or forward movement, the system creates a forward-biased vacuum gradient. This asymmetry in the Casimir effect propels the craft by shifting the local spacetime metric, enabling smooth, controlled travel without the need for traditional engines or propellants. Acceleration in AEON-CASIMIR is achieved by ramping the metric index over time. This allows the craft to change velocity smoothly, without generating thrust or experiencing inertia shock. The process is controlled and precise, ensuring safety and efficiency during rapid speed changes. Turning in the AEON-CASIMIR system is accomplished through tensor rotation, rather than applying lateral force. By rotating the inertial tensor, the craft can change direction instantly and precisely, all while maintaining stability and coherence in the vacuum-metric system. For extreme maneuvers, AEON-CASIMIR employs inertial tensor decoupling. This advanced technique allows the craft to perform rapid, high-stress movements without experiencing structural shock or internal forces. The system's ability to decouple inertia is a testament to the power of vacuum-metric engineering. Unlike conventional propulsion systems, AEON-CASIMIR does not require thrust vectoring. All movement is achieved through precise manipulation of spacetime metrics and vacuum energy, eliminating the need for complex mechanical systems and increasing reliability. Stability in the AEON-CASIMIR system is maintained through phase-lock plasma rings. These rings help synchronize the vacuum-metric configuration, ensuring that the craft remains coherent and responsive during all modes of operation. Metamaterial resonance tuning is another key to maintaining coherence in the vacuum-metric system. By carefully adjusting the resonant properties of the metamaterials, AEON-CASIMIR can dampen decoherence and maintain precise control over the propulsion system. Boundary feedback control is used to actively monitor and adjust the vacuum-metric configuration. This real-time feedback ensures that the system remains stable, even in the face of external disturbances or rapid changes in operating conditions. Decoherence in the AEON-CASIMIR system appears mathematically as noise in the stress-energy tensor. This noise is actively damped through advanced control systems, ensuring that the craft remains coherent and efficient during all phases of operation. One of the most revolutionary aspects of AEON-CASIMIR propulsion is that it requires no propellant. All movement is achieved through vacuum-metric engineering, eliminating the need for fuel storage, exhaust systems, and the limitations of reaction mass. Despite its radical approach, AEON-CASIMIR propulsion preserves causality and respects the principles of relativity. All operations occur within the boundaries of known physics, ensuring that the system is both theoretically sound and practically viable. AEON-CASIMIR is an engineering system, not a speculative or promotional concept. Every aspect is grounded in rigorous physics, with detailed diagrams, equations, and technical plates supporting each claim. This commitment to scientific rigor sets AEON-CASIMIR apart from other advanced propulsion concepts. The first technical plate in the AEON-CASIMIR dossier is a 4K cutaway diagram of the Casimir cavity propulsion system. This plate provides a detailed look at the internal geometry, plasma ring topology, and field vectors that make the system possible. Every element is labeled and attributed, ensuring clarity and reproducibility. The second technical plate maps the stress-energy tensor across the vacuum-metric system. This 4K diagram visualizes how energy is distributed and manipulated, providing a clear reference for understanding the underlying physics of AEON-CASIMIR propulsion. The third technical plate presents the effective mass tensor diagram. This 4K image demonstrates how the system reduces inertial resistance and enables extreme acceleration by reshaping the vacuum-modulated potential. Every aspect is carefully detailed for maximum clarity. The AEON-CASIMIR project proceeds in well-defined phases, each building on the last. From foundational physics to advanced engineering diagrams, every deliverable is designed to provide a clear, logical progression. This structured approach ensures that each concept is fully developed and supported by rigorous evidence. In summary, AEON-CASIMIR propulsion represents a radical departure from traditional aerospace engineering. By leveraging the properties of the quantum vacuum and the principles of general relativity, it achieves movement without thrust, propellant, or reaction mass. Every aspect is grounded in established physics, with a focus on engineering rigor and reproducibility. This is not just a new engine, it's a new way of thinking about motion itself.